Chapter 6, Angles and Parallel Lines, Part 2. In this part of the chapter, we'll be looking at some of the properties of parallel lines and transversals, and what are corresponding angles, alternate angles, and interior angles between parallel lines. So, what are parallel lines? Now, when two straight lines on the same plane do not intersect with each other, okay, they are called parallel lines. We often use the symbol, this one that looks like two slanted lines, okay, to represent is parallel to. So for example, in the diagram over here, we have AB is parallel to the line CD. So more often than not, students always write their answers, right? Then they try to do this, right? So this is actually not a correct representation or the correct usage of the double line. Okay, so please do not use this in your answers. Right, next one, let us see how do we draw two lines that are parallel to each other. You can find out more also by watching the video, a live demonstration of using the set squares through this video over here. Okay, to draw two lines that are parallel and through the use of a set square, so first we need a ruler itself, and then we need the set square over here. So you can see that this is our set square and this is our ruler. So first we begin by drawing a straight edge using the ruler. Next, we shall put our set square such that it's at a 90-degree edge itself against our ruler. And then we slide the ruler on the edge, right, maybe slightly upwards, using the set square to help us to fix it in position. Okay, and then we'll move it a certain space away from the original line, and then we'll draw another straight edge again. And now we will have two parallel lines. We'll indicate these two parallel lines with an arrow in the same direction. Okay, so in this case, let's say for example, if I label this AB and this one is CD, then we will have the lines AB to be parallel to CD. Now that we already know what are parallel lines, let's find out what's a transversal. A transversal line, okay, when a line that cuts two other lines, for example, the line inside the diagram over here, we have ST or TS, the line TS cuts two other lines, right? And the line, two other lines are AB and CD. This line is called a transversal. Okay, and what are some of the angles that are being formed? Right, a pair of angles is being formed by a transversal line. The first one we have the corresponding angles. Corresponding angles are angles that looks like a letter F over here. Look a little bit like a letter F. So these are the corresponding angles, where you have this one over here to correspond to this angle over here. I shall call this and label this point maybe X, and this point of intersection to be, show Y be, okay, Y. So in this case, we know that angle TXB and angle TYD these are called corresponding angles. Right? And not only that, we also have a pair of alternate angles. Alternate angles are angles that look like a little Z. Okay, so these are the alternate angles. I should use a red color, okay, to describe these two. And you can see from here that angle BXY will be alternate angles with angle XYC. So these are called the alternate angles. Okay, last but not least, we also have a pair of interior angles that are being formed. Interior angles will look a little bit like letter C or letter U, or Okay, something like a letter U but rotated, or letter C rotated in different ways. So in this case, you can look at the angles over here. This one, AXY, and the angle XYC. They are called interior angles. Now, knowing this type of angles, let's move on further to explore the different properties of this type of angles. Now, in the next part of the lesson, we will explore some properties about the transversal and parallel lines itself. Now, we already know that a transversal line cuts the pair of parallel lines, and they can form corresponding angles, alternate angles, and interior angles. But if they cut specifically a pair of parallel lines, there are some certain angle properties that comes along with it. Now, if you like to, you can use the GeoGebra applet in the link over here to visit this whole GeoGebra applet, and you can play around with it, drag the points, and observe some of the properties. Okay, but what are some of the values of the angles that has been formed, and what can we conclude from some of these? Okay, so what we have down over here, okay, is quite obvious. The angle TOB in this case here, which is 50 degrees, actually equals to the other angle TPD. These are called corresponding angles on parallel lines, right? Because the two lines are parallels, when a transversal cuts it such that you have this angle over here that forms like a little bit of a letter F, right? This angle over here is exactly the same, equals to this angle. So they are equal. So because it's a line pair of parallel lines and it's a pair of corresponding angles, therefore they are equal. Next one, we also can observe that the angle BOP, which is the angle over here, BOP, okay, this angle is actually 130 degrees. This angle is actually equals to the angle over here, which is the angle OPC. Alright, so in this case, what do you notice? They form a letter Z. It looks something like a letter Z over here, and this angle and this angle are equal. So these are called alternate angles on parallel lines, and when they are parallel lines, these two alternate angles will be equal to one another. Next one is also easy to observe, that angle BOP, this 130 degrees, and if you notice the angle over here, also change the other color, OPD, these two angles, one is 130 degrees, the other one is 50 degrees. These two angles add up to a sum of 180. So these are the properties. This is because they are interior angles on parallel lines. So when two interior angles that forms like a shape of a letter C, or a C being rotated, okay, these two angles will on parallel lines will always add up to be 180 degrees. Right, with that we can actually summarize some of the following properties, and each of the different angle properties comes with an abbreviation that you can actually use, right, for your writing and presentation when you write the reasons itself. The first property, corresponding angles on parallel lines. First condition, they must be parallel lines first, okay, and if you have a corresponding angles, they will always be equal to each other. The abbreviation is written as such over here, corresponding angles, parallel lines, right? The next one will be that the alternate angles on parallel lines are equal. So it must be a pair of parallel lines, then the alternate angles will be equals to each other. So the abbreviation will be alternate angles on parallel lines. Right? Last but not least, interior angles on the same side of the transversal is supplementary. So if I have these two parallel lines, I have the transversal on the same side, so interior angles over here, these two will always add up to 180 degrees. So interior angles on parallel lines. So these are the proper proof and presentation when you write your angle properties. Now, knowing these angle properties, let us explore a little bit on how we actually use these angle properties to help us find and calculate some unknown angles, and what are the way we write the representation for our working. So if I were to find the angles P, Q, and R, the first one we can observe to find angle P over here. Angle P, and the only angle given is the angle 115. Angle P in this case over here is a pair of alternate angles. So we know that angle P is equals to 115 degrees. Reason being, we write the reason usually in brackets. This is alternate angles on parallel lines. Secondly, we can find the angle Q. Now, although I think some of you already know 115, you'll take 118 minus 115 to give you angles on the adjacent angles on a straight line. But alternatively, we can also look at using the properties of a pair of parallel lines. So this too is actually called a pair of interior angles. So angle Q will be equals to 180 minus 115 to give you 65 degrees, and the reason being, okay, this is called the interior angles on parallel lines. We usually write the reason in brackets. And last but not least, I can use it to find angle R. Okay, obviously we can find using vertically opposite angles, or rather if you were to use the angle properties of parallel lines, you'll see that there's a letter F over here. Then in this case, angle R will be equals to 115 degrees. This is simply by the property corresponding angles on parallel lines. Okay, now have you gotten the concept? I'll leave the rest of the exercises for you to try out and for your teacher to go through with you. So I'll see you for the next session. Bye.